Welcome to Babu. Now we will start an important topic in algebra, that's polynomial. Usually it's important we have to give more attention to this part. Before we go into different aspects of polynomial, let us briefly discuss some applications of polynomial. We can take the case of professionals. Among the career professionals, one most likely to use polynomial on daily basis are engineers. Engineers use polynomial to model cars, to design roads, buildings, etc. Economists use polynomial to model economic growth pattern. Medical professionals use polynomial to study the behavior of bacterial colonies. That is why it's a polynomial is an integral part, an essential tool to solve more problems in real life. This video about polynomial cover all the aspects including MCQs. The length of the video is nearly about 90 minutes and we divide this 90 minutes duration video into 3 equal parts. So let us start the first part of polynomial. Now go through the topic polynomial. I have already told you that polynomial is a big concept in algebra. Before we try to understand polynomial, we need to learn about some words associated with algebra and polynomial. First we look what's meant by algebra. Algebra is a branch of mathematics to represent problems or situations in form of mathematical expressions. That is, it is a branch of mathematics used to represent situations and problems in form of mathematical expression. Or we can say that algebra is a branch of mathematics that deals with symbols and numbers and arithmetic operation across these objects. Every branch of mathematics, that is calculus, coordinate geometry, trigonometry, all involves the application of algebra. Next we will look what is meant by mathematical expression. What is the mathematical expression? I'm very familiar to you. Mathematical expression is a mathematical statement composed of terms. That's very important. Terms and operation. I have written another sentence here. It is analogs to English sentence, so it may be called mathematical sentences. That is, in mathematics, expressions is analogs to English sentence. That is why I use this statement here. English sentence involves English words associated with the English meaning. Mathematical statement involves numbers, operators, and symbols, etc. The difference is one type we use English language and other type we use international language. Which is the international language? Math is the international language. So mathematical expression involves variables like x, y is numbers 1, 2, 3 and arithmetic operators, addition, multiplication, division, etc. to form a meaningful sentence. That is mathematical expressions. Here I give some examples here. 5x plus 6. We usually call it as algebraic expression. Similarly, x square minus 2x plus 1. It is also an algebraic expression. This expression 9 plus 5, it is familiar to you. It is called arithmetic expressions. Mathematical expressions which contains fractions are called fractional expressions. Example 1 by 4 plus 2 by 3, etc. Next we will learn what is meant by this one, term. What is meant by term? A term, a word that familiar to you in English language, but what is the meaning of term in mathematical context? Term is a single mathematical expression consist of a variable or a constant multiplied by a variable or variables, sometimes variable raised to a power. It may not be a confused sentence. I will explain a little bit in detail. A term is a single mathematical expression. 5x is single mathematical expression. 6 is single mathematical expression. In this algebraic expression, x square minus 2x plus 1. X square, a single mathematical expression. Minus 2x, another expression. So, a term is a single mathematical expression. While we give the correct definition, we say that term is a single mathematical expression consists of a signed number. Sometimes it may be plus, sometimes it may be minus. Signed number or a variable or a signed number multiplied by a variable. Here minus 2, signed number multiplied by a variable x. Here plus 5, signed number multiplied by a variable x. Or variables. Variables means sometimes it may be minus 3xy or plus 2xy variables, or sometimes variable raised to a power x square. That means term is either 5x or 6, a constant term, or minus 2x, a constant multiplied by a variable, or x square, etc. That is meant by term. One important thing is each term in an algebraic expression is separated by plus sign or j sign. Terms are separated by plus or j sign. Plus or j sign. You never get confused with on j. J sign is used in complex numbers that you will study in higher classes. So you don't worry about j at this time. Term in an algebraic expression. In this algebraic expression, term is separated by plus sign. Sometimes it may be noted in some textbooks that terms are separated either by plus or minus. It's wrong. Only plus. Here the terms are x square minus 2x plus 1. This term is called plus 1, 6. These are all called constant. So, never forget that thing. Terms in an algebraic expression is separated by either plus or j sign, not minus sign. We will what's mean by coefficient. As when a term is made up of a constant multiplied by a variable, a single variable or variables, that constant is called coefficient. Let's consider this expression. 2x square minus 3xy plus 7. 3 terms are there. 2x square minus 3xy plus 7. We take the first term, 2x square. Here a constant 2 is multiplied by the variable, power of the variable x square. Then this constant 2 is called the coefficient of x square. Consider the second term, minus 3xy. Here the constant minus 3 is multiplied by variables xy, then this minus 3 is called the coefficient of xy, and this 7 is called the constant. So these words in algebra are essential to understand polynomials. Next we will do polynomial. Polynomial is a type of expression. It is also a mathematical expression in which exponent of all the variables should be a whole number. That's very important. Exponent of all the variables should be whole number. That's very important. Whole number. That means a non-negative number. When we take this expression 2x square minus 3xy plus 7, what exponent of this variable? Yes, a positive number 2. What's the exponent of xy? Yes, this is also a positive number. This is a constant term. Here is a variable is there. That is x raised to 0. It is a whole number. Whole number means 0 along with the positive numbers. Positive integers, that are called whole number. X raised to 1 by 2. The exponent is a fraction. It is not a whole number. So x raised to 1 by 2 plus 2. It is not a polynomial. Square root of x plus square root of y. It is not a polynomial. That is, square root of x can be represented as x raised to 1 by 2. It is not. 1 by x. It is not a polynomial. That this 1 by x can be written as x raised to minus 1. So this is not a polynomial. So all polynomials are mathematical expressions. All polynomials are algebraic expression, but all expression may not be polynomials. X raised to 1 by 2 plus 2, it is an algebraic expression, but it is not a polynomial. Square root of x plus 1 by x, it is algebraic expression, but it is not a polynomial. All these such problems, problem related to all these concepts we do in a separate slide. Okay. So next we will look some examples polynomials. 2x square plus 4xy plus y. How many variables are here? There is 2 variables. Exponent of all the variables are whole number. That is, exponent is 2. What is the exponent of this term xy? It is also 2. X raised to 1, y raised to 2. That is, exponent of all whole term is sum of the exponent of the every variable. Here y is y raised to 1. It is also a whole number. So this is a polynomial in one variable. Consider this example. X cubed plus 2x plus 1. 3 terms are there. Here, exponent is 3, a whole number. Exponent of x here, second term, is also a whole number. 1, x raised to 0. We may assume that x raised to 0. So, whole number. Power of all the variables are whole number. So, this is a polynomial. We can also say that polynomial in one variable. Then we will look how we name the polynomial. If the polynomial contains a variable x or y, or z, whatever it may be, then if the variable is x, then we denote the polynomial as px or qx or gx, etc. So this polynomial can be written as px. Px is equal to x cubed plus 2x plus 1. That is it. Here I write on example, here I show on example, px is equal to x plus 3. Then, how can we write this on pxy? 2 variables. Okay. In this session, we will study polynomial with only one variable. There are polynomials with many variables, like x square plus 4xy plus y square, something like that. So you will study polynomial with many variables in higher classes. Now, we will study few terms that are used to describe polynomial based on the number of terms and degree of the polynomial. Degree of the polynomial means the highest power of the variable used in the polynomial. First we will look name of the polynomial based on the number of terms. Consider this polynomial 3x or x square. These polynomials have only one term. Such polynomials are called monomial. Consider these polynomials. X plus 2, x square plus x, 4y square plus 3. 2 terms are there. If a polynomial has 2 terms, then that polynomials are called binomials. Consider this polynomial y square plus 4y plus 5 or 2x cubed plus 4x plus 5. These 2 polynomials are 3 terms. Polynomials with 3 terms are called trinomials. Then polynomial with many terms are called multinomials. Usually we will use these 3 terms, monomial, binomial and trinomial. Then we will look the name of the polynomial based on the degree of the polynomial means the highest power of the variable used in the polynomial. Consider this polynomial x raised to 6 plus 1. The variable used here is x. Power is 6, so degree of the polynomial is 6. Consider this polynomial y square plus 4y plus 5. In this polynomial, variable is y, highest power variable is 2, so degree of the polynomial is 2. So, next we will look name of the polynomial used to describe, specific name of the polynomial based on the degree of the polynomial. If the degree is 1, that is consider this polynomial x plus 1, t plus root 2, y. In these 3 polynomials, the highest power of the variable is 1. Such a polynomials are called linear polynomials. Its general form is ax plus b. The maximum number of terms in a Linear polynomial is 2, minimum 1. So this condition is also there. That is, the general form is ax plus b. The condition is a should not be 0. If a turns to 0, then polynomial is b. It is a constant polynomial. Next, consider this polynomial 5 minus y square and 6 minus x square. Here 2 terms, here 3 terms. Based on the number of terms, this is binomial, this is trinomial. Okay. Now, here we concentrate only on degree. Here the degree of the polynomial is 2. Here the degree of the polynomial is 2. That is, highest power of the variable. These polynomials are 2. If the degree is 2, then that type of polynomials are called a quadratic polynomial. Its general form is ax square plus bx plus c, and one condition is there: a should not be 0. If a becomes 0, this polynomial becomes bx plus c, degree is 1, then it will become linear polynomial. So the condition is a should not be 0. What will be the maximum number of terms? 3. Minimum 1. What will be that time? X square. Consider this polynomial: x cube plus 4x square. Number of terms 2. Degree 3. Highest power of the variable is 3. Such polynomials are called cubic polynomials. General form is ax cube plus bx square plus cx plus d. Maximum number of terms 4. Minimum 1. What will be that time? Ax cube. Condition is a should not be 0. So is there any relation between maximum number of terms and degree of the polynomial? Yes, there is a relation. Maximum number of terms is degree of the polynomial plus 1. Minimum 1. 1 term. Next we will look general form of the polynomial, one variable. That is, I have already told you, we will study polynomial with only one variable. General form. General form is a n x raised to n plus a n minus 1 x raised to n minus 1. Here a n and a n minus 1 etc. a 0. These are all constant. This a n is called not nth term, coefficient of the x raised to n. Coefficient of variable x raised to n. A n minus 1 is coefficient variable x raised to n minus 1. And this a0 is called the constant. And in this general form, condition is there: a n should not be 0. That is, I have already told the conditions here. There is a general form of the polynomial, one variable with the degree n. Degree n. Then, if these constants a0, a n minus 1 etc. a0 turns to 0, then this polynomial becomes 0 polynomial. And one important point here, it is degree of the 0 polynomial is not defined, not 0. Degree of the 0 polynomial is not defined. It may be asked in MCQ. Degree of the 0 polynomial is not defined. Okay. So these are all the specific names used to describe polynomial based on the number of terms and the degree of the polynomial. Never confused with the degree of the polynomial. Degree of the polynomial is the highest power of the variable used in the polynomial. Next we will do some exercises based on the concepts that we have studied in polynomials. First one. Which of the following expressions are polynomials? Check the reasons for your answer. We have already studied that polynomials are mathematical expressions in which exponents of all variables should be whole number. Consider the first one. 4x square minus 3x plus 7. Here the variable is x. Exponent of the variables are whole numbers. Is it? Here the exponent of x is 2, here exponent of x is 1. This is a constant term. If we consider about this one variable, then this is exponent is 0. So this is a polynomial and non-variable. Exponent of x is whole number. Consider this one, second one. Y square plus 2 root 2. 2 times are there. Then the variable used here is y. Exponent of y here it is 2. This is a whole number, so this is a polynomial on variable. Consider this mathematical expression 3 root t plus t root 2. This is a mathematical expression in variable t. Here root 2 is right after t. That is, if it is used, avoid the confusion. If root 2 is right before t, then naturally a doubt will come. This root will include also t. In order to avoid that confusion, root 2 is right after t. Exponent of t here is root. That means 1 by 2. So it is not a whole number. So it is not a polynomial. Here exponent is 1. But all the exponents of the variable here it is not whole number. So it is not a polynomial. Then consider this one, fourth one. Y plus 2 by y. 2 times are here. Variable used here it is y. Exponent of y for the first time is 1. Consider the second time 2 by y. The power here is y raised to minus 1. It is not a whole number, so it is not a polynomial. Consider this one, fifth one. X raised to 10 plus y raised to 3 plus t raised to 30. 3 variables are there. In this mathematical expressions, the exponent of the variables are all numbers. So this is a polynomial. Polynomial in 3 variables. Okay. Next, write the coefficient of x square in each of the followings. Consider this mathematical expression 2 plus x square plus x. We just concern only about term with x square. What's the coefficient here? Coefficient is the constant multiplied to a variable in a mathematical expression. Here it is 1. So the coefficient of x square is 1. Consider this second one. 2 minus x square plus s cube. 3 terms are there. But we concern only about x square. So the coefficient of x square here it is minus 1. Consider this one, third one. Pi by 2x square plus x. The coefficient, the constant multiplied to x square, that is pi by 2. So pi by 2 is the coefficient of x square. Next, root 2 into x minus 1. Is there any term x square? No. So there is no term in the x square. So there is no coefficient for x square in this mathematical expression. Give one example of binomial of degree 35 and monomial of degree 100. Binomial means polynomial with 2 terms. Its degree should be 35. Degree means highest power of the variable used in that polynomial. Here answer is 4 y raised to 35 minus 3. 2 terms are there, so it is a binomial. This 4 is not required. You can also write it as y raised to 35 minus 3 or x raised to 35 minus 3 or r raised to 35 minus r. Whatever it may be. Condition is 2 terms should be there and degree of the variable should be 35. Then second one. Monomial of degree 100. Monomial means polynomial with only 1 term. But its degree should be 100. Here I write 6y raised to 100. You can avoid this 6 also. You can write it as y raised to 100 or x raised to 100 or a raised to 100. Whatever it may be. No problem. If the degree should be 100 and there should be only 1 term. Next question. Write the degree of each of the following polynomials. Degree means the highest power of the variable used in the expression. First one, 5x cubed plus 4x squared plus 7x. The variable here it is x, highest power is 3, so degree is 3. Second one, 4 minus y squared. The variable used in the expression is y, highest power is 2, so degree is 2. 5t minus 7. The variable used in the expression is t, highest power is 1. So the degree of the polynomial is 1. The next one, 3, a constant polynomial. The variable used here may be x, y, z, whatever it may be, and its degree is 0, x raised to 0, 1, y raised to 0, 1, t raised to 0, 1, whatever it may be. So the degree of a constant polynomial is 0. Answer of the second one is 2, third one is 1, and fourth one, a constant polynomial, so its degree is 0. Classify the following as linear, quadratic and cubic polynomials. That means classify the following polynomials based on the degree of the polynomial. Linear means degree 1, quadratic means degree 2, cubic means degree 3. Take first one, x squared plus x. The variable used here is x, highest power is 2, so this is a quadratic polynomial. Second one, x plus x cubed. The variable used here it is x. The highest power of this variable is 3, so it is a cubic polynomial. Then third one, y plus y squared plus 4. The variable used in this expression is y. The highest power used variable is 2, so this is a quadratic polynomial. 1 plus x. The highest power is 1, so this is a linear polynomial. 3t. Variable used here it is t. Only one term is there. The highest power is 1, so this is a linear polynomial. R square. Only one term. Highest power is 2, so this is a quadratic polynomial. 7x cube. Only one term is there. The highest power of the variable is 3, so this is a cubic polynomial. So all we have to do is classify. This is a label, that is what are the linear polynomials here, quadratic polynomials here, and the cubic polynomials. Okay, you can do it yourself. Before we go to factorization of complex system represented by polynomial, let us take a brief look at how to find the value of a polynomial for a particular value of the variable. Factorization means rearrangement of the complex system represented by the polynomial as a bunch of linked smaller system. That we will study on the next section. Okay. Now, let us look how to find the value of a polynomial for a particular value of the variable. First, we take an example: 5x minus 4x squared plus 3 at x is equal to 0. What we have to do? We have to put a value of x as 0 in this expression and do the necessary arithmetic. Then we will get the answer. That is, here we will take px as 5x minus 4x squared plus 3. That is, I put the name polynomial as px. Then substitute the value of x as 0 and do the necessary arithmetic. 5 into 0. Substitute x with 0 here. Here it is 0. Minus 4 into 0 square plus 3. Then we will get the answer as 3. Don't confuse this with this is an equation. This is not an equation. This is an expression. I keep the name this expression as px. Okay. Then next one. Find the value of this polynomial at x is equal to minus 1. X is equal to minus 1. What we have to do is substitute the value of x as minus 1 here. Then while we do the necessary arithmetic, what will be the answer? I just leave answer for you to do the calculation. 5 into minus 1 minus 4 into minus 1 whole square plus 3. Then minus 5 minus 4. What will be the answer? Minus 9 plus 3. Minus 9 plus 3 means minus 6. So this is the answer. The minus 1 is equal to minus 6 and P2 is equal to 5 into 2 minus 4 minus 2 square plus 3. That's the answer is minus 3. So once again I emphasize the point, don't confuse this as px is equal to 5x minus 4x square plus 3. This is not an equation. So naturally a doubt will come, what is the difference between this one equation and expression? Consider this one. 5x minus 4x square plus 3 equals 0. This is an equation, but this is an expression. So the major difference between an equation and an expression is the equal sign. Here an equal sign is there. That's all these things you have studied in earlier classes. An equation contains equal sign and expression does not. This is an expression, but this is an equation. An equation contains two expressions on either side of the equal sign. This is one expression, only here 0 is there. This is also an expression. But an expression contains just terms and operations. Another important thing. Equations must be solved. This is solved for the value x. But the expressions are only evaluated. Don't confuse. It is wrong to say that equations are evaluated. These equations must be solved. But expressions are evaluated. Evaluate the expression for the variable x is equal to 0. Evaluate this expression for the value x is equal to minus 1. So, in order to evaluate an expression, we need to plug values. Put the values for any variable and do the arithmetic. That's what we have done here. In order to evaluate an expression, what we have to do? We just plug or put the value of the variable in this expression and do the necessary arithmetic. In order to solve this equation, what we have to do? First, we have to isolate the variable and do the necessary arithmetic. Find P0, P1 and P2 for each of the following polynomials. That is, evaluate the polynomials. Polynomial for y is equal to 0, y is equal to 1, y is equal to 2. That's the meaning. So what we have to do? Put the value of this variable y as 0 in first expression and do the necessary arithmetic. It's very simple concepts. That is, substitute y for 0 here. Then we will get the answer as 1. Then P1 means substitute the value of y as 1 here. Then we will get the answer is 1. That is, put the value of the variable y as 1. The next, just plug the value of the variable as 2 and do the necessary arithmetic. We will get answer 3. Similarly, what's the variable here? T. What we have to do? Put the value of t as 0 and do the arithmetic. Put the value of t as 1 and do the arithmetic. Okay. Why we give the name p? In these questions we give it as p. So that's why we put the name as pt, py, px, something like that. So what will be the answer? It's a very simple concept. So this is the answer. Pt as this one, P0, P1, P2. Similarly, S cube. The fourth one is left for you. You can do yourself. So this is method find value of the polynomial for a particular value of the variable.